Hey everybody, I think this is the last week of videos. Oh my goodness. And that gnawing that you're hearing is my dog. It sounds like a stampede, but it is literally just my dog chewing on a bone. And I'm in the basement and he's upstairs and it's that loud. How impressive. Okay, so our last thing you will see kind of right away. Hopefully you'll make connections to this actually in geometry, where you transform shapes. So this is called transforming quadratic equations, and we've been doing quadratic equations for the last few weeks. And it's a little bit, obviously we're still working on quadratic functions, but it's also about transformations, which is something that you'll see in Algebra 3-4 and pre-calculus as well. So the first thing I want to talk about is what's called a parent function, and that's the most simple or basic function in a family. So it's basic. And so it's almost like the most boring, nothing's been changed. It's just the way we kind of see this. And so you've actually been exposed to 3 parent functions without calling them parent functions. Linear is just y equals x. It's this diagonal line where 1 equals 1, so the points are like 1, 1, 2, 2, 0, 0, negative 1, negative 1. It's like a perfect diagonal line that goes across the origin. Then you have this exponential function, and you've never seen this e number before, or at least not in our class, but you'll see this more as you get especially into pre-calculus. And so this is considered the parent function for exponential. And then the quadratic equation. So there's no y equals x squared. So there's just a 1 in front of there. There's no constant being added. The vertex is at 0, 0. And we're going to talk about briefly what the graph looks like. So when I graph this, 0, 0 is the vertex. And we can just do this really quickly. So when you think of x is negative 2, when we square that, negative 2 times negative 2 is a positive 4. So we go to negative 2 up 4, and then negative 1 squared, negative 1 times negative 1 is just 1, so it'll be negative 1, 1. 0 squared is just 0. 0 times 0 is still 0. And then it's symmetrical. It has parabolas, which make them another cool thing to see the movement in quadratics, and it's really the first time that you talk about transformations in algebra, because you can really see how they move left, right, up, down, get fat, get wide, or get thin. They have an axis of symmetry, and so that's just going to be on the y-axis there. 1 times 1, or 1 squared, is 1, and then 2 times 2 is 4. So 1, 1, and then 2, 4. So this is our basic parent function when it comes to a quadratic or a parabola. So in transformations, we have actually specific words for each transformation. And the first one is called a translation, and that's just shifting. So we take this thing, we don't make it fatter, we don't make it skinnier, which are called stretches or shrinks. And we just move it. So we take this shape and we're just like moving it to the left or to the right, moving it up, down, moving it to the left, and then moving it up, something like that. So translations are just shifts. They don't change the shape, they're just moving the location. Left, right, up, down. All right, so to see the movement of this is the new parent function. So y equals the quantity x minus h, close to the power of 2. So there's your quadratic, x is squared here, plus k. And so h really moves left, right, left and right. So that is, and if you notice, it's opposite. So if you see a minus 3, it's actually going to go to the right or to the positive direction 3. And so that's with the x, which, x moves left and right, and it's in with the x. And then there's k. K moves up and down. And so a quick note, if you had k with the y, it'd be a y minus k. just like the opposite in here. If it was with the y, if it was on the same side, it would be the opposite too. And then h and k become the vertex. So really when you think about this one, and if you would want to write it in this form, it would just be, and I'll do this just kind of quickly off to the side, it would be y equals x minus, well, our vertex here, or that point of where it kind of goes symmetric on both sides, 0 squared plus another 0. Your k, or your vertex here, is 0, 0. So again, this just simplifies, well, x minus 0 is just x, so that's x squared, and then we just don't need that because that can be understood. So that's, you know, another reason why, like, you could write it this if you wanted the vertex to be 0, 0. And that's another reason why it's so easy to see the movement, is you just can see the vertex. So if it's, you know, if the vertex is 3, 2, then it moved to the right 3 and up 2, because usually it's at 0, 0. Let's do some examples to make some more sense out of this. Okay, so example 1, we have this given right here. We've got our equation, and we're gonna describe the translation. So let's remind ourselves what that generic, h squared plus k. So for this one, the h, let's do some colored pencils. So h is equal to 2. And so now I would say, can you locate the k? So the vertex is 2, 3. So if you want to describe it, well, from 0, 0, you know, the original is at 0, 0. If we wanted to describe it, we would say right 2 units. And that's your h, so it goes that way, and the 3 is a positive, so it's going up. And up 3 units. Okay, so if we want to graph it, we could put the original maybe in a lighter blue. So let's talk about the original. So the original kind of looks like this. And I scaled this axis differently, which I didn't need to, but I might need to with all this moving. So we've got, from the notes before, it's 1, 1. So it'll be right there, and negative 1, 1. And then 2, 4. Again, this is my parent, and then 3, 9. So that's 8, so 9 is in the middle. And then negative 3 times negative 3 is a positive 9. So this is like this is that basic parent function, and I'll draw it in and I'll make it kind of light. Okay, and so every point we're gonna move 2 units to the right and 3 units up. So I'll do the new one in my actual colors. So I'm gonna go over 2 and 3 units up. For this one, 3 units is actually each half, just because of the way I scaled it. And for our purposes, it's actually, if you just rewrite where the vertex is at 2, 3, then Khan Academy will be happy with you, and so will I. But so we go over 2, 1, 2, and up 3, 1, 2, 3. Again, the up movement is just halves because of the way I scaled it. So we're gonna go over 2, 1, 2, and up 3, 1, 2, 3. And I can also look at the vertical and double check. Over 1, 2, up 1, 2, 3. Over 1, 2, up 1, 2, 3. And that can be enough for our purposes for this one. So here is my new function. And you can see how it's just, the shape should not have changed. It should not have gone wider or narrower, but it just, every point translated over 2 and up 3. All right, let's go over this example. So the parabola y equals x squared is shifted down 6 units and right 5 units. What is the new equation? So I like to say what h is. So if h is right is positive, it goes in this direction, which is positive on the graph, so it's a positive 5. Again, it shows up as the opposite in the equation, so it's going to say minus 5. And k is shifted down 6. So down is a negative direction on our graph. So it's a negative 6. So we have this fun equation, y equals, parentheses, x opposite h squared plus k. And then I can make my little highlighters. So there's my h is 5, and that goes right here. And then my k, what color was that? Red. My k is a negative 6, and that's right here. So I'm gonna write it out like I do the most, and then I'll simplify quick, and you don't have to do the most when you do this on Khan Academy. So I said plus a negative 6, but plus a negative is really minus. So to clean this up a little bit, minus 6. You don't need a plus a negative, that's just minus. And if it was a negative 5, if this went left, then it would be negative negative, and so then it shows up as a positive. So if it's in with the x, you think this goes back 5 because it's a negative, but it's the opposite direction as kind of intuition tells us. All right, the next video will have 4 examples from Khan Academy.